Alright, let's look at the homework 7.3, problem number 9. Alright, so first we're gonna complete the square, then do a trig substitution to evaluate this integral. Alright, so let's do that. Alright, so first inside the square root, we have t squared minus 4t. Right. So to complete the square, we would like to have 4. So I'm going to do add 4 and subtract 4. Right. Then we still have plus 29. Right. But I'm going to group the first 3 terms together and group the constant terms together. So this is going to be, this is going to be, right, so these 3 terms will make t minus 2 squared, right? Then negative 4 plus 29 is 25, so 25 is 5 squared, so I'm going to put the 5 squared. Alright, so we can rewrite this guy as integral, right, dt over square root of 5, I'm going to write 5 squared plus quantity x minus 2 squared, right? So we can use the tangent substitution. So we're going to let x minus 2 be, a is 5, so it's a 5 tangent of theta, right? Then go through the derivative. Derivative of x is dx over d theta. And derivative of negative 2 is 0, so it goes away. And derivative of 5 tangent theta is 5 secant squared of theta, right? Then we can multiply both sides by d theta to get dx is equal to 5 secant squared of theta d theta. Right. All right, so let's do the substitution. So this is going to be integral. Right. So dt, oh, actually, let's see, I messed it up something. Yeah, all right. I was using x instead of t. Sorry about that. So I'm going to just erase this guy. So this should have been t there. All right, and also here, this should have been t there. Right, and not dx, dt over d theta goes here, right? So this is going to be here, dt is equal to that. All right, so dt is 5 secant squared of theta, and I'm going to put the d theta down here, right? Alright, and this is going to be square root of, right, 5 squared plus 5 squared and tangent squared of theta. Alright, so we can simplify this, right? Pull out the 5 squared with the square root, so this is going to be just a 5. And 1 plus tangent square is secant square with the square root, so this is going to be just a secant of theta. Alright, then we can do a cancellation. 5 on top, 5 on the bottom. There's a secant square, so one of the secant cancel out, so we have that. Alright, so we have antiderivative. We're going to have to find the antiderivative of, only thing left is secant, right? So antiderivative secant is natural log of absolute value of secant of theta plus tangent of theta plus some constant c. All right, so we need to find these guys. So I'm going to use right triangle. So just draw a general right triangle. Alright, and I'll put theta there. Alright, so substitution equation, and so here I have that right there. Right, so I'm going to divide by 5 to get tangent of theta is equal to t minus 2 over 5. Right, and remember that the tangent is opposite over adjacent. So we can let the opposite to be t minus 2 and adjacent to be 5. Right? Then using the Pythagorean Theorem, you're going to have a square root of t minus 2 squared plus 5 squared, which is the same thing as the original one. So I'm going to write the t squared minus 4t plus 29. Right? Alright, so let's find what we need. So we need to find the secant of theta. Alright, secant of theta is going to be, let's see, I'm going to just do it here. Secant of theta is going to be hypotenuse over adjacent. So you have a square root of t squared minus 4t plus 29. And adjacent is 5. Alright, and the tangent of theta, and which you already know, it's a t over 2 over 5. Alright, so this is going to be a natural log of absolute value of square root of t squared minus 4t plus 29. Right, over 5, and plus t minus 2 over 5 plus c. Right, but when you have a fraction, we can split that into natural log of absolute value of square root of t squared minus 4t plus 29 plus t minus 2, right, and minus natural log of 5, right, plus some constant c. I'm going to use c prime, c prime, c prime, so that I can combine these two constant terms, then write it as just c, right. So what you get is natural log of, and we might not need the absolute value here because this is going to be always a positive quantity. So maybe I'll just put the parentheses here. Right, so you have t squared minus 4t plus 29 plus t minus 2 plus some constant c. Right, so this is the antiderivative that we are looking for. Alright, so let's type it in. Alright, so we have natural log of square root of t squared minus 4t plus 29 plus t minus 2 plus some constant c. Right, so let's submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.